as we take a look today, ladies and gentlemen, we're going to do graphing of sine and cosine. Okay. In the next few days, we'll be starting to graph. So these guys, I'm going to show you some of the visuals, kind of help you guys out. Now, before we actually dive into graphing these things, just go back to what we've learned in the past with quadratics. You guys remember what this is a graph of, right? That's a graph of a parabola. And then we started moving these things around, right? We had what we called transformations. And if we had an x squared plus 2, what did that plus 2 do? You guys remember? Huh? It went, yeah, the thing went up, right? So that was a transformation up. Well, today when we do sine and cosine waves, it does the exact same thing. Okay, that's what we call our vertical shift. If it's positive, it goes up, and if it's negative, it goes down. Okay. Then we dealt with numbers in front. Let's say if we had a negative x squared. You guys remember what happened to that? What happened when you had a negative x squared? Huh? Yeah, it's a frowny face, right? The thing went upside down. Same thing happens with sine and cosine waves. If you have a negative in front of sine or cosine, you're going to see the whole graph get flipped upside down. Okay. And if we had like 3x squared, you guys know what happens with 3x squared? Doesn't get flipped. It's still a smiley face if it's positive. What does happen, Mary? Or are you just stretching? Brandon? Yeah, it gets vertically stretched. It looks a little thinner. Goes up a little faster, gets stretched vertically. Same thing happens when we're talking about our sine and cosine waves today. So all those transformations are going to hold true. Eventually, we'll see the ones that move left or right, like x minus 2 squared. We know that one, or should know. Opposite of what you see in parentheses, that's going to be a shift to the right. So we're going to see a lot of these guys today, but now with sine and cosine. Okay, so let's take a look. Again, that's our goals for a graph transformations of sine and cosine. And we'll be doing that by looking at goal number 2 is the amplitude and period. So as we take a look at our equations, we got the A, we got the B, the C, the D. Today we're going to focus on A. And A is for your amplitude. That's going to be that stretch vertically. Or it could compress your graph. Okay. If it's like a fraction or something. So A is your amplitude. Now, technically, A is always positive. So I'll put an absolute value around that thing. A is always positive. If there's a negative in front, your A value is going to be positive, and then just click on MyMathLab, it'll be the reflection over the x-axis. So when you graph these things on MyMathLab, there'll be the sliders and stuff that will be moving. B's for your period. Period is the time of which this graph replicates. So if you guys remember, sine and cosine, when we graph those on our unit circle, it repeats after 306 degrees. Kind of what we talked about yesterday in chapter 6.3. It goes around 360 degrees and then starts replicating. Like 390 was the same thing as 30. Okay, and so on and so forth. It continues on to replicate. So to find the period, which for whatever reason they use T for period and not P, they have period as 2 pi over B. All right. So the B value is that number that's in front of X. So if there's a number in front of X, we take 2 pi and divide by that. And that's going to compress or stretch your graph horizontally. We're going to talk about phase shifts later in 6.6, so I'm not going to worry too much about that one. But the D value, that D value is that vertical shift like we talk about with quadratics. That D value is moving in up or down. Positive goes up, negative goes down. Okay. All right. So to get you guys in the right frame of thinking, I've got our unit circle here. And we talked about all the different quadrantal angles as we went around. We talked about 0 and 360, which is 2 pi. Up here is 90, which we know is pi over 2. This guy is 180 or pi, and this one's 270, which is 3 pi over 2. And again, 360 is the same thing as 2 pi. So as we go around that unit circle, we hit those quadrants. quadrantal angles, multiples of 90. And we talked about the three numbers that we had here. Okay, so I have those on the sideboard for us. 0, 1, 0. Reminder, that is in terms of our famous phrase, SOHCAHTOA. SOHCAHTOA. And we go through and we got all these other ones up here. That's IOU in terms of SOHCAHTOA. 1, 0 undefined. This is 0, negative 1, 0. In terms of SOHCA and TOA. And then last but not least, we have down here is negative IOU at 2, 7. Negative 1, 0, and undefined for SOHCA, TOA. So what we're going to do is we're going to graph this thing in terms of sine. I've got y equals sine of x, and we're going to graph it over an x and y axis. Now, to kind of help us visualize what's going on, I'd like to take a second and show you like what it looks like in real time. So I'm going to go over here, look at a little website here. So as we're going around this circle here, gang, we're going around this circle right here at 0. Sine is 0, 1, 0. Which one is sine? 0, 1, or 0? 0. So at 0, sine starts at 0. Then up here at pi over 2, what's pi over 2 up there? 1, 0, u. Which one is it? It's 1. So at pi over 2, it's going to go up to 1. Pi over 2 is about 1.57. And then at pi, it goes back to 0. It's the first number listed, so at pi, it goes to 0. And then at 3 pi over 2, it goes to negative 1, and then it goes back up to 0. So that's the idea of what the sine wave is. This represents one period of sine. And then after that, it starts replicating. So as I scroll down, this right here represents one period of sine, and then you cut and paste it over and over and over, and it's just replicated over and over for infinite amount of times. Okay, and this is what a sine wave looks like. Okay, where do you think you would see sine and cosine waves? In real life, where would you ever see those things? Think of waves. Where would you see waves like this? Physics class. Where have you seen these waves? Any ideas? Sound waves, frequency waves. Perfect. Okay, the different changes in the frequency is going to change, your wave that we're going to get. Different amplitudes going to change the different frequency you're on. Okay, microwaves, right? You guys use a microwave every day. Guess what we're using? Okay. All right. So that gives the idea of where we're going. Now let's put this into action. Let's actually graph this thing by hand. Amplitude is your A value. So amplitude is your A value. That's the number in front. So in this case, your A value is just 1 because it's y equals sine of x. There's no number there, so it's just a 1. So this is 0. And amplitude is the distance from the middle to the top of your graph and from the middle to the bottom. So from here to here is your amp. And from here to here is your amplitude. From the middle to the top and middle to the bottom. Your period, there is no number in front of x, so it's just 1. So 2 pi over 1 is just 2 pi. So this is going to start at 0, and it's going to go all the way to 2 pi. Now, if you think of our unit circle up here, we split this unit circle into how many parts? This thing's been cut into what? 4s. So we're going to need 4 tick marks. So we take this period, we split it in half, and then we split those into halves, and now I have 1, 2, 3, 4 tick marks that I got to label. If I take 2 pi and I divide it in half, now I'm at 1 pi. And if I take pi and I divide it by half, now I'm at pi over 2. And now if I add these two together, 1/2 plus 1 is 1.5 or 3/2 pi. Okay. Another way to look at that is what we call intervals or tick marks. We need to come up with this tick mark value or intervals. All we need to do is take our period and divide it into 4. If we take our period, 2 pi, divide by 4, we get pi over 2. The 2 and the 4 reduce. So what that means is the distance between each tick mark is an interval of pi over 2. We can just start adding 1/2 over and over. 0 plus 1/2 is 1/2 pi. 1/2 plus 1/2 is 2/2, which is 1 pi. 2/2 plus 1/2 is now 3/2, and 3/2 plus 1/2 is now 4/2 or 2 pi. So that's another way to look at your intervals. Okay. A lot of you guys have your quadrantal angles memorized, which is great, but from time to time you're going to see your period change. So this idea of the intervals might help you. Okay. All right, so let's graph this thing. We're going to go around our unit circle up here. And as we take a look, it's in terms of SOHCAHTOA, so we're looking at that first number for sine. All of these guys I'm circling up there is for sine. So at 0, sine is 0. So I got 0, 0. And then at pi over 2, we're at 1. And then over here at pi, it goes back down to 0. And then at 3 pi over 2, it's at -1. And at 2 pi, now we're back to 0. So it goes up, it goes down, it goes down, and it comes back up. Arrows on the ends of your graphs because it continues on in that fashion. This represents one period of pi. I can cut this out and paste it over and over and over and replicate it. That's just one period. Okay. Good. For sine and cosine, they always start at 2 pi and start replicating, unless there's a b value. There's no number in front of x. There's no b value, so our period's going to be 2 pi. So good question. All right, any others? Yeah. So it goes in order. So the question is, which one is which? So I have all 3 numbers, and it's always in form of SOHCAHTOA. Sine is first, cosine is second, tangent's third. So SOHCAHTOA, sine, cosine, tangent. Sine, cosine, tangent. Sine, cosine, tangent. So sine's always the first, cosine's always the second, and tangent's the third. Okay, good question. You guys good? All good questions, gang. All right, so we take a look at the next one. Now I've got an A value. Okay, so I like to show you guys this little slider show I got here. So this is a basic sine wave, right? As I take a look, it starts at 0, 0. It goes all the way up to 1, then down and down and goes back up. So this is sine. I have our values that we're going to be messing around with today. I've got A, B, and D. And as I take a look, A is the value that we're seeing here. What's going to happen with my graph if I change this value? What happens when I change the A value? Right? Yeah, it's going to, remember this is the A value for a quadratic, right? If I had 2x squared, what's going to happen with the graph? It's going to get stretched vertically, right? Same idea. As this A value gets bigger and bigger, look at my graph. Okay, so I'll stop here with an A value of 4. Look at how high it gets to. It gets to 4, and look at how low it gets to. It gets to -4. Okay. As I move this value smaller and smaller, my graph gets smaller and smaller. And as I approach 0, what happens to it? Becomes what? Becomes a line, because 0 times sine is just 0, and I get a horizontal line. Okay. And now if I go to negative, you see what happened? Normally sine over here goes up to 1. Well, now it's getting reflected over. Now it's been flipped over that x-axis. So now it's going down, okay, to -1. Does that make sense? And if I move this even farther away, if I go to like -3, now it gets as low as -3 to start, and then goes as high as +3. It's gotten reflected and stretched. Okay, so let's go ahead and graph that now by hand. Let me get this back in order. All right, so when we have y equals 3 sine of x, that's our vertical stretch. So that's our amplitude. There is no b value there, so that's going to be 2 pi. And then there is no vertical stretch or shift yet. This guy right here, again, if you haven't figured this out, this guy right here is for the y-axis. So amplitude is what we use for the y-axis, and the period is for the x-axis. Okay, so I go ahead, I start at 0, and now it's getting stretched up to 3. And it's getting stretched down to -3. My period is 2 pi, so I'm going to go from 0 to 2 pi. I cut that in half, and I cut those in half. When you guys do this by hand, try to get these values, this distance between tick marks, as equal as possible, because they're the same distance away. Try to make it nice and pretty. So I cut it in half and cut those in halves. Now it's pretty well segmented. So if I take 2 pi and cut it in half, now I'm at pi. If I cut that in half, now I'm at pi over 2. And now that last one is 3 pi over 2. All right, sine starts at 0. And then where does it go? It goes up. And now there's nowhere else to go but down. And you go one step at a time. I go down. I was already up, so there's nowhere else to go. Now I got to go back down. Now I come back up. Again, these are U shapes or curves, waves, not V's. And then arrows on the ends of your graphs. Okay, quiz or test, you're freaking out like, I don't know what that 3 does. Your calculator does. But first thing I want to make sure is that I'm in radians. So double check if you're going to throw this in your calc with me. Make sure your calculator's in radians. So go to your mode up here, click radians, and now go to your y equals. I'll put in the original sine of x. So y1 is just sine of x, and then y2 I have 3 sine of x. And then I graph it. I'm in zoom 6, zoom standard when I graph it. Here's the original sine of x graph. And now here's the red one that's stretched by a factor of 3. You can see it definitely on this graph that's been stretched by a factor of 3. I can even verify this, and let me know if you're not getting this graph. I can verify by go second trace value and plug in 0. For the blue one, I got 0, and if I use the directional pad for the red one, I also got 0, so they started 0, 0. Now, if I want to check what happens at pi over 2, just type in pi divided by 2, and that's all the way up to 3. Where in the original one, if I go down, that's at 1. And then I can check all the other points on my graph just to make sure pi. That's at 0 for the blue one, and it's at 0 for the red one, and then so on and so forth. Okay, anybody not getting those graphs? Got to be in radians. If you're not in radians, you're not going to see these waves. You're going to see something totally different. Okay? All right, any questions with sine? All right, let's take a look at the next one. I've got y equals sine of x plus 1. This time, this is the d value. Okay, so as we take a look, I'd like to show you guys this guy here. This is y equals a sine of bx plus d. The d value is plus 1. What's going to happen if I change this from 0 to 1? What's happening to your graph? Where does it go? As you start moving up, the graph moves up. And as you start going towards the negatives, now it's moving down. That's that vertical shift. 0 here. Now it moves up to 1. So normally sine starts right here at 0, 0. And as it got shifted up 1, now it's starting at 0, 1. Okay? The amplitude is still 1, so the highest it's going to get is 1 plus 1, which is 2. And the lowest it's going to get is all the way down to 0. Okay? All right, so let's put this in action. Go ahead and graph this guy. So the way I do it, just to make it easy, again, I have an amplitude of 1. There's no number in front of sine, but there is a vertical shift. This vertical shift is plus 1. So if you're using MyMathLab, you're just going to use your little slider and move your vertical shift. And these two work together for the y-axis. Those guys work in the y-axis together. Okay. First thing I do is my vertical shift. Normally I start at 0, but now I'm going to 1. And now I count up and down my amplitude. So if I count up 1, that puts me at 2. And if I count down 1, that puts me at 0. Okay, so when I'm doing this by hand, I just make this my new axis. Amplitude, I still have 2 pi. There is no b value yet. We'll see that in a few minutes. This guy's 2 pi. I cut that in half. I cut that in half and that in half. So again, that's pi. That's pi over 2. That's 3 pi over 2. Sine usually starts here at 0. Now it gets shifted up 1 unit. Then it goes up. Then it goes down. Goes down. Back up. You want to think of them kind of like semicircles. They're not really semicircles, but that at least makes you think that it's curved. And gives you a rough sketch of what that period looks like. Okay. Now, this is really not your axis. I just make it that way when I draw them by hand. This is really your original x-axis, this guy going across. Okay, but everything's been shifted up 1 unit. For me, it's just easier to draw it that way. Okay. All right, any questions with sine? Give me a thumb. Where are we at, guys? Is this pretty easy? Okay. Again, when you're doing MyMathLab, it's just a bunch of sliders. It should be pretty easy. Okay, we're going to switch gears. We're going to do cosine. When we're graphing cosine, I always like to think of our quadrantal circle again. So I've got y equals cosine of x so that we see it. I'm just going to draw it above it. Going around the horn, we know these numbers are 0, 1, 0. IOU, 0, negative 1, 0, and negative IOU. When we look at cosine, these numbers are in terms of SOHCAHTOA. So which one's cosine? Which one are we looking at? What do we want? First, second, or third number? Number 2, Kylie says. Good. So 1, 0, negative 1, and 0. Okay. Some people like to see this live, so I'm going to go ahead and show you the live version. So looking down at cosine here. You guys see at 0, over there at 0 degrees, 0 radians, cosine, 0, 1, 0 is the middle one, 1. So this thing starts at 0, 1. It starts up. Then at pi over 2, IOU, cosine 0. So it goes down to 0. Then it goes down to negative 1 at pi. Then it works its way up to 0 and then back up to 1. Okay, so again, this is what cosine looks like over lots of periods. So from here to here, from 0 to 6.28, which is 2 pi, 2 times 3.14, 6.28. That represents one period replicated over and over and over. Okay? All right, so that's what it looks like. So let's draw this thing out. Looking at our 3 numbers, my amplitude is 1, my period is 2 pi, and there is no vertical shift. So this thing starts at 0, amplitude is 1, so let's get as high as 1 and negative 1. Again, we know our period is 2 pi. So we got our quadrantal angles, pi over 2 pi, 3 pi over 2, and 2 pi. And now we go around the horn. At 0, cosine's 1. So it starts up here. At pi over 2, it drops it down to 0. Over here at pi, cosine's negative 1, so it's down here. Then at 3 pi over 2, it's back to 0. And then at 2 pi, brings us back to 1. So the idea is it goes down, it comes up, and it comes up right here. All right. And that's what a basic idea what cosine looks like. And then again, it's replicated over and over and over. Now, from time to time, you might see example 5 where they have y equals cosine of pi x. This is our first time where we see a b value. So it's y equals cosine of bx. This is our b value. This is what we use for our period. So this is the first time that we have seen something that affects it. So the formula for period on the front is 2 pi over b. Why they use t, I have no idea. They should use p for period, but let's make it tough. Go ahead and put the b in there, pi, and then simplify. The pi's cancel, so I get my period to be 2. All right. So amplitude is 1, so again 0 to 1 and negative 1. And here we go. I'm going to go from 0 all the way to my period of 2. I cut that in half, and now I cut it into fourths. Well, take 2 and cut it in half. Where are you at? This is 1, right? 2 divided by 2 is 1. And if I take 1 and I cut it in half, now I'm at 1/2. And now if I want the other one, add them together. 1 plus 1/2 is 1.5, which is 3/2. Just without the pi's. Okay. You can use that same idea of interval. Interval is just your period divided by 2. Or excuse me, your period divided by 4, because there's 4 quadrants. So take 2 divided by 4, you get 1/2, and just keep on adding 1/2 over and over. All right. So here, and the cosine goes down, then it goes down, then it comes up, then it comes up. And these are humps, hills and valleys, I call them. So you got a nice little hill, now you got a nice little valley. Now we got a nice little hill, nice little valley. Okay. Arrows on the ends of your graphs, we continue on. Now when you see this graph and you see this graph, you're like, I don't really get what's going on here. So let's take a look at the slide, or what happens really when you put those numbers together. Now I know I have sine here. I can change this to cosine. Let's see if I can't type in cosine. All right, there's cosine. And we had a b value this time. What happened to our period when that b value was pi? What's happening to your period as that b value gets bigger and bigger? What's happening? It's going this way, right? It's going side to side. Now, is it going to get stretched when the b value is big, or is it going to get smaller when the b value is big? Think about what we did. We took our period and divided by b. So the bigger b is, what happens to your period? The smaller it gets. It's always opposite of what you see in parentheses inside of the function. So this is actually, as it gets bigger and bigger, it's getting compressed like a slinky, like a spring. Okay? Versus as it gets smaller and smaller, now it's getting stretched out. And eventually, if you hit 0, it becomes a horizontal line. And if it becomes negative, now it gets flipped over that y-axis. Okay? So kind of cool there. All right, so that gives you kind of the idea what's going on there. Let's move this back down. that thing's getting stretched vertically. So if you look at the graph now, between the two, put some numbers to this. This thing goes from 0 to 2. Well, this one goes 0 to 2 pi. 2 pi is about like 6 something, right? 6.28. So you can see this one's really been collapsed. Okay. All right. Now, I try to make this as painless as possible so you'll see the graphs almost look identical. That way it's easy to graph for you guys. All right, let's do, which one do you want to do here? Let's do, well, I think we need to do both of these, unfortunately, because there's some stuff that's going on. So let's take a look at number 6. We'll do these quick for you guys. I've got y equals cosine of x minus 3. This time I do have an a value and a d value. I've got an amplitude of 2, and I got a vertical shift of negative 3. Okay, just a reminder, those are on your vertical axis, your y-axis, up and down. So I always mark this guy with my shift. And then I count up my amplitude. So this distance from here to here is your amp. So if I'm at negative 3 here, and I add 2, what does that put me at? That's negative 1, very good. And if I subtract my amplitude, if I count down 2, where does that put me? Negative 5, perfect. And then you have your period. You guys get that, right? Pi over 2, pi, 3 pi over 2, and 2 pi. That hasn't changed at all. Cosine, again, starts up here. It goes down. It goes down. It comes up, and then it comes up right there. Now we got a nice, pretty looking graph now. I've got my x and y axes labeled. This is what I'm looking for on a quiz or test. I'm looking for these numbers here, and I'm looking for these numbers here, and I'm looking to see that you have it starting and going the right direction. Okay. Beautiful thing, quiz or test, you're freaking out, I have no idea. Type it in your calculator. You'll have at least a good idea what this thing looks like. You'll have a good idea where it starts, where it goes to. Yep. Yeah, period's 2 pi. Yep. All right, last one I want to graph, so thanks, Viv. Last one, I got number 7. I've got number 7. I've got y equals negative 2 sine of 1/3 x. OMG. First things first, I got an a value, and I got that b value. Amplitude is technically always positive. So whatever this number is, always say it's positive, in this case, positive 2. But the negative, what does the negative do? What does the negative do? Think of a negative x squared. What does the negative x squared do? Flips it. This is a reflection over that x-axis. So I got a reflection over that x-axis. Period is 2 pi over b. In this case, I've got 2 pi divided by 1/3. If you need to use your calculator, take 2 divided by 1/3, or just simplify it. How do you simplify something like this? Rand? Yep, multiply by the reciprocal, 3 or 3 over 1. And 3 times 2 pi I get is 6 pi. So that's 6 pi there. And there is none there for a vertical shift. So this thing is starting at 0. My amplitude is 2, so 2 and negative 2. Also be careful, guys. This is sine, not cosine. So where we start is going to be different. Last but not least, I want to fill out my vertical or my horizontal axis here, my x-axis with my period. This thing is going from 0 to 6 pi. I cut that in half. What's half of 6 pi's? How much you got? 3 pi's? And then I take 3 pi's and I cut that in half. How much is that? 3 pi over 2? How does that work? Now, the hard one is coming up with this one. This is where intervals is nice. Okay? So if I'm looking at my interval, again, period divided by 4. If I take 6 pi and divide by 4, I've got 3 halves. So this is 0 plus 3 halves is 3 halves. 3 halves plus 3 halves is 6 halves. This is 9 halves. Now, you're like, what? How do you get that? That's okay. 7 out of 5 people are bad with fractions. If you're bad with fractions, that's okay. Take 6, divide by 4, that's your interval. That's your first tick mark, 1.5. So if you need to, math frac, put a pi on top. You get 3 halves. Keep on adding that interval over and over and over. So add 1.5. That's 3 pi. Add 1.5. That's 4.5. Math frac. That's 9 halves. Plus 1.5. There's your 6. So take your period, divide by 4. Take 6, divide by 4, and we get that 3 pi over 2. And we can keep on adding that over and over, and if you need to, math frac as you go. Okay? Cosine is no longer, we're using sine here. So be careful which one you're using. We're using sine. Where does sine start normally? At 0. And then usually it goes up to 1. But then it got stretched by a factor of 2. And then it got flipped. So it goes down to -2. And there's nowhere else to go but up. I already went down, so I got to go up again. And there's nowhere else to go but down now. So it got reflected. And it looks like that. So your nice, pretty graph of sine. Okay, amplitude is 2 with a reflection, and now your period has been changed to 6 pi. The hard thing, I think, is sometimes these fractions. But if you just take your period, divide by 4, and just keep adding that over and over and over in your calculator, it makes it very easy. At least it should. Last question. Number 8. I know it's almost time to go, so let's do this real quick. Is this sine or cosine just by looking at it? What do you think? Take a guess. It's sine. Why? Yeah, it starts at 0, 0, so we got sine. They want us to figure out our A value and our B value. A is our amplitude. From the middle to the bottom. There it is. It's going down, so it's a reflection. Normally sine goes up. So that's our A value. It's either positive or negative. In this case, it's going down, so it's negative. B is for our period. If you guys remember, period is 2 pi over B. So if I want to solve for B, take 2 pi and divide by my period. Well, my period starts at 0, and where does it start replicating? Tristan's giving me the peace sign too. The thing goes down, up, and that's the cutoff. That's our period. So we get T is 2. So if we plug that in, 2 pi divided by 2, the 2's cancel. I get pi for B. So I get pi there. And there you go. So there's going to be 2 things you have to figure out. I think all the ones I've given you are sine, and then you got to figure out what's your A value. If it goes down, it's negative. If it goes up, it's positive. And then you got to figure out your B value. Just take 2 pi divide by your period, and you should get B. Ladies and gentlemen, that is it for today.